Hello everyone, my name is Kalyan and I am excited to announce RetailPulse Intelligence, an end-to-end customer analytics system. In today's retail landscape, the business is drowning with data but starving from insights. I processed 1 million of data to predict customer spending tire with high precision, and I am proud to share that this model has shown 88.95% predicted accuracy. Working with the data of this caliber, 1 million rows requires more than a script and architecture. So I implemented Databricks Medallion Architecture. Starting with the bronze layer, I uploaded the raw data set into the Unity catalog. In the silver layer, I performed all the heavy lifting like filling the null values, feature engineering, etc. And the gold layer contains all about the business data sets from which we can create dashboards and valuable insights that you will be seeing shortly. Let's move on to the technical work. I noticed that my dataset contains number of null values in different columns, and all these null values are depending upon the age feature. So I implemented age bin mode imputation method, which is used through which I have filled the null values present in my dataset. I also performed feature engineering. I created a new feature named is weekend through which I can able to capture behavioral differences in shopping pattern. I also performed target encoding for more than 50 plus states present in my dataset. However, the biggest technical challenge is Spark metadata conflict. While vector assembly, one of my feature was treated as categorical even though it's numeric. So I developed a solution in order to solve this problem. So instead of talking about the code, let me show you the program in practice where I have performed the null value, filling the null values using mode bean imputation method. So here I checked whether the null values missingness of the data is random or not in just a single column. And here I checked for all the columns where the null values are present. And after checking, I came to know that the null values are missing. I mean, it is not in random, but instead it is depending upon the average age and the amount spent. So since that amount spent is my target column, I included only the average age and I performed the age based, I mean age bin mode imputation method on all the columns which contains null values. And now the resultant data set is free of null values. And let me show you here. I counted the null values and there were no null values here. Let me show you the feature engineering process that I have performed on my dataset. This is the schema of my dataset, and this is the value counts that I performed on my dataset. And these are the categorical columns that are perfect for one hot encoding as they have low cardinality. But there is this one feature which is having high cardinality, which is this feature is having more than 50 states. So I have performed the target encoding on this data set on this column, and this is the resultant data set that I got after performing one hot encoding and target encoding. These vector type columns are the result of one hot encoding, and this is the target encoding resultant. And I also used this transaction date, which is of timestamp, and created a new feature named is weekend, which will tell whether the current date, I mean current day is a weekend or not. So as I said earlier, I was getting a problem with the Spark metadata, right? So for this column, state names target column, I was getting the problem where the Spark is assuming that this column is categorical even though it is a numeric. As you can see here, even though it is, I mean continuous, even though it is a continuous column, the Spark is assuming it as a categorical. So I changed the metadata of it and the problem has been resolved, and I was able to successfully train the model with 88, I mean 0.88995 accuracy. Now let's talk about the model performance and governance. The machine learning model that I have used is random forest classifier because of its simplicity and interpretability. This model is also robust to small noises that might be present in my dataset. I also performed hyperparameter tuning with more than different types of variables, and all these metrics are tracked using MLflow. I will be showing you the the MLflow UI that is present in the Databricks. So this is the runs section where the machine learning model training and the metrics are stored, which are being tracked using MLflow. So as you can see here, there are a number of wrong, that tracking is cancelled because due to the technical problem, as I said earlier, that was happened due to metadata conflict. And this is the random forest classifier without any hyperparameter tuning. And as you can see, the accuracy is 0.88945, which is approximately 89%. And if you see the random forest model with hyperparameter tuning, the accuracy also the same. And as you can see, the number of trees were 100 here. And when I compare the both random forest and the random forest with hyperparameter tuning, both of them will be having the same accuracy, as you can see here. Now let's move on to the most important part, how businesses turn this massive data into valuable insights. As you can see here, more than 80% of the predictions were correct, and this indicates the feature engineering that we performed is correct. And if you see this histogram, you can see that more than 90% of our predictions fall within the high confidence, and the random forest model is not making random guesses. This confusion matrix, or you can say the heat map, will be very helpful in identifying where the model is wrong and where the model is getting right. As you can see here, for 82.23k data points, the model predicted as premium, and it turns out to be correct. And if you see the average confidence by spend tier, there are three types of spend tier: basic, premium, and elite, which is of the highest tier. For premium tier, the confidence is higher, and for the elite tier, the confidence is low among all the three. So now let's move on to the most important visual, or you say valuable insight, which is total customer volume by predicted tier. As you can see, the tree graph that is present here, this orange color indicates the premium tier, and the green color indicates elite tier, and the blue color indicates the basic tier. The elite tier persons who are visiting the shop are more than the premium tier, and the blue, the basic tier customers are the highest among the three. So this visual tells us that we have to put into the efforts in order to convert this basic tier customers, which are of highest 6.64k, to become either premium or elite. You can convert the basic first to directly elite, or basic customers to first premium, then to elite customers. To conclude, retail pulse intelligence proves that with the right architecture, we can turn massive data into actionable strategies. In future, I am planning to automate this using Databricks jobs for real-time customer prediction. Thank you for your time and giving me the opportunity to participate in 14-day Databricks AI challenge. I am happy to take any questions through LinkedIn or GitHub. Thank you very much.